Hi folks, welcome back to Physics with Captain Rod. I'm sorry, Math with Captain Rod. Most of my videos I make are about physics topics, but anyway, so I'm making this video here to provide a couple examples. These examples are on page 49 of your college algebra text. We're going to look at numbers 8 and 16. So let's talk about this animal here. So b to the fourth plus 12b squared plus 27. So a lot of the polynomials that you tend to look at, a lot of them are like have squared terms and then a linear term and then a constant. This one doesn't. This one has this fourth power term and then this squared term. And one of the things we can do here is we can simplify this down with a little algebra trick here. What I'm going to do is I'm going to let x equal b squared. And the reason for doing that is that this term here, b to the fourth, would then equal x squared, because that would be, b squared squared. And that's going to allow us to rewrite this polynomial and make it look a little bit friendlier. So this guy right here we can write now as x squared plus 12 times b squared, which is equal to x, plus 27. And now this polynomial looks a little bit more friendly. Now, there's no common terms, but it should be easily factored with that kind of trial and like guess and try it approach. Lead term here is 1x squared, so no doubt it's going to be x and an x. Then we look here, factors of 27, well, 27 and 1, 9 and 3, and then I notice that's a 12 there, so the 9 and 3 very likely. And when you check this, it works. There's your x squared term plus 3x plus 9x. There's your 12x and plus 27. And now what I'm going to do is I'm just going to replace the x with b squared, because that's what it was equal to. And this is now done. One thing I'd like to point out, here's a like b squared plus 3 squared. Well, remember, the sum of two squares does not factor. The difference does, but not the sum. So neither of these are factorable. That thing is done. All right, let's take a look at this guy, number 16 here. So we're looking at this, and I chose this one again because it's kind of a strange looking one with this n up here in the power, and we got to say, like, what are we going to do with this thing? Well, you'll notice that this is a to the 2n. And that a to the 2n, let me write this off to the side. You can write that a couple different ways. One would be this, a to the n squared. That would equal a to the 2n, because remember, when you raise a power to a power, you multiply your exponents. So we can do a similar type of algebra trick here. Let's let x equal a to the n, because then a to the 2n we could then write as x squared. And that's going to allow us to rewrite this polynomial as 2x squared plus 9 times a to the n, which is what I'm temporarily calling x, plus 9. And now we have something that looks a little bit more user-friendly here. So I think I'm going to use that, again, guess and hope it works type of approach. Lead term, no doubt, we got this 2x squared, so if it factors nicely, it's going to be 2x and x. Pluses everywhere in sight. Factors of 9. Let's see, let's try 3 and 3. 2x squared plus 6x plus 3x. There's my plus 9x plus 9. So that thing is done. So here's some examples here of, oh, I'm sorry, did I say it's done? Not quite yet, because we still have x's, but the original problem had these a's in it. So the very last thing to do is just resubstitute x is equal to a to the n. So this one we can write as 2a to the n plus 3 times a to the n plus 3. And now it's done. Get rid of that done term. Now it's done. So We put a smiley face because we're happy. We're mastering our factoring here. So hope this video helps get you through your homework on page 49. Have a great day.